you will learn how to make this character controller. We can move it using the AWSD keys. We have the sprint feature when I'm holding the shift key. Also, we have a special transformation. If I hit Control, you see that we can turn it into a ball. In this mode, I can move it using the AWSD keys with a different speed. And also we can get back with the Control key. And you will notice that the animation is different. So if we open it in the same position, we have this animation. But if we are moving, he opens like that. So before we get started, make sure to subscribe to my channel. That helps me a lot. And without any further ado, let's dive right in. As you can see, I've already created an empty project. So I want to start this from scratch without using any starter assets. First of all, we have to download the robot model. I'm going to use a free asset from the Unity Asset Store, which is this robot that comes with the animations that we need for our gameplay. You could also customize it with different textures. As you can see, we have the open animation. I think it's really cool. To download it, you have to open it in Unity. I've already done that, and it is this robot sphere folder. And before we start using the 3D model under this asset, which is this robot sphere, I want to create an empty game object as the base of our player using right-click, create empty, and let's call it player holder and reset the transform. After that, I will add the 3D model, so make sure to drag it under the player holder. For now, you can't see it because it's really tiny. Let's change its scale to 40 on the X, the Y, and the Z. Then let's add a plane as a ground using right-click, 3D object, plane, and let's call it ground. Make sure it's outside of the player holder. Reset the transform, and let's scale it a bit. The material is a little bit boring, so I want to assign this prototype material. And now it feels better. So if I hit play, nothing happens. We can't move this sphere using the AWSD keys or do anything. We're going to implement this from scratch. So to move this player holder using the AWSD keys, there are two ways. You could use the rigid body component or the character controller component. In this video, I want to use the character controller. So search for the character controller component and add it to the empty game object. Then we can use its built-in method, which is called move, to move the robot ball. So when you add the character controller component, you will see that we have this kind of capsule, which is some sort of collider for our player. We want to adjust it to fit with the 3D model. In our case, we have a sphere. That's why I'm going to use 2 as the radius and move it a little bit to the top by changing the center point. And that's really important for the player movement and collision. Now that we have the character controller component, we're going to use the new input system to check for the inputs. And to do that, we have to add the new input system package from the package manager using window, then package manager. Make sure that Unity registry is selected and search for input system. Let's hit install to add it to the project. And if you don't know how to use the new input system, make sure to check out one of my previous videos. I've talked about it. Then hit yes and save to restart the project and set up the new input system. And to use the new input system, there are different ways. In this video, I'm going to show you the easiest one. We have to select the player holder and we are going to add the player input component. So this comes with the new input system. Once you add it, let's hit create actions. And we can give it a name like controls. And if you hit save, you will see this window that pops up. As you can see, it is separated into 3 parts. We have the action maps, like the player action map. If you select it, you will see the different actions that are related to the player, like the move action to move it using the AWSD keys. So this is all set by Unity. The look action so that we can rotate the camera and make a third-person camera movement. Now to use the move action and move the ball using the AWSD keys, we have to create a C# script under the same game object that has the player input, and we will add the onMove function. So this will look for these functions, which is going to be called each time we use the AWSD keys or the joystick to move the ball. So let's go under the assets and create a C# script. I'm going to call it player inputs manager. As I said, we have to attach it to the player holder. Then we are going to create a function. First, you have to add the new input system namespace using Unity engine, then dot input system, and you have to write it like this, on, then the name of the action, which is move, and this takes an object of type input value. Let's call it value. And to get the inputs, we use value dot get, and then we add the type. In this case, it's a vector2 that represents the movement along the x and the z. And to use this vector, I'm going to create another variable on top using public vector2. I'm going to call it move equals the value vector2. Now we can use this vector in other scripts so that we can move the ball using right click, create C# script. I will call it robot controller. Then let's attach it to the player holder. And under this script, we are going to access the character controller and use the move function to move our player using the move vector. So let's open it up. First, we need a reference to the player inputs manager so that we can get the move vector. And then let's initialize it under the start function using getComponent, and we want to get the player inputs manager script. Of course, we need to add a reference to the character controller. The same thing, let's add private character controller, and set it using getComponent, character controller. Now we can move on to the update function, which is called over and over again. As I said, we are going to use controller.move. So this is a built-in function that takes the direction and it will move the player towards that direction. And let's add input.move, which is the vector2 under the script. And we can multiply it by some sort of speed and by the time, the delta time, to make it frame rate independent. I haven't created this speed variable. Let's add it on top. I will add serialize field so that we can adjust it from the inspector. And it's going to be a float, speed equals 4. Make sure to save all of your scripts. Then let's hit play. As you can see, we can move the ball left and right. But the only problem is that when I hit the W key, it is moving up and down. And that's because we are using this vector2 directly. To solve that, let's create a new vector3. I'm going to call it target direction equals new vector3. For the x, I will use input.move.x to move the player left and right. For the y, I'm going to use 0 because I don't want to move the player up and down. And to move it forward and backward, we use input.move.y. And finally, we have to change the vector to the target direction. And there you go, it is working. We can move the ball using the AWST keys. But there is no animation, and the game looks boring. I will use the animator component of this robot sphere. For now, we didn't have a controller to set the animations. We can right-click, create, animator controller, and let's call it animator. Then we have to apply it to our 3D model, robot sphere, by dragging the animator under the controller field. And let's double-click on it to open it up. For now, it is empty. There is no animations. Let's go under the robot sphere, assets, and we want to go to the animations. For example, let's take a look at this idle loop animation. You have to select the animation section and hit play. Let's use it as the default one by dragging the animation to the animator component, which is going to set it as a default animation. And there you go, we have our ball idle by default. Now we have to switch between idle and walk when I'm moving. And the way we do that is by adding another animation and add some kind of transitions between these. Today I want to use something unique that comes with the animator feature, which is called the blend tree, that will blend between the animations. So instead of using this directly, we can right-click, create state, then we have from new blend tree option. If you open it up by double-clicking on it, we can add different animations. Then we can blend between them using this parameter. For now, it is called a blend that we can adjust from the code. Don't worry, I'm going to explain this step by step. Under the inspector, we can add different motions or animations using the plus icon and add motion field. You could also add another blend tree. And then we can add a second one because we have idle and walk when we are moving. You could pick up an animation using this dot, or we can simply drag it from the assets. So we have the idle one. Let's drag it like this. And the second motion is the walk animation, which is this one. Let's select the blend tree again and drag the walk loop animation under this motion. And let's hit play. Now we can smoothly switch between these animations by changing this blend parameter. So if it's 0, it is idle. And as we increase it, it will switch to the walk animation. We're going to adjust this from the code. For now, it is called blend, but let's rename it to speed. First, we have to add a reference to the animator component using private animator. Under the start function, I'm gonna set it using getComponent. But this is going to check for the animator component that is attached to the player holder that has the script robot controller. We need to get this component from the robot sphere, which is a child of the player holder. So instead of using getComponent, we can use the getComponent in children, and it will take the animator component. Next, we can access the speed parameter using animator.setFloat. This takes a string, which is the name. In our case, it is called speed. You could simply use input.move. Then we can access the magnitude of the vector, which will take the length. So if we are moving, it's going to be 1. Otherwise, it's going to be 0. And that's what we want. Before we test it, make sure to change the blend parameter to speed under the parameters tab. And there you go. The robot is idle by default. And when we start walking using the W key, as you can see, he switches to the walk animation. And it is smooth because we're using the blend tree. For now, we are not rotating the ball towards the direction where we are moving. We need to convert the move vector that has the XY values, which is this vector, and get the angle between the forward vector, which is the Z axis, and the move vector, so that we can rotate the player towards this direction. And to get this angle from the X and the Y values, you have two options. We can use some built-in functions that takes in the move vector and change it to an angle or quaternion. And the second option is by using some trigonometry functions, because the tangent of this angle equals the opposite over the adjacent. In this case, the opposite of this angle is this value, which is the X, over the Y, which is the adjacent. And then we can get the angle. For me, I will go with the first option because it's easier for me. We can use a built-in function, which is quaternion dot look rotation, which takes the target direction and it will convert it to an angle. So let's pass it in. Then I can use transform dot rotation equals this quaternion, and let's hit save again. And there you go, we can move the ball. Also, we can rotate the player towards the direction where we are moving. But it's not smooth at all because it snaps directly to the new rotation. And to apply a little bit of smoothness, instead of assigning this rotation directly to the player, we can use quaternion dot slurp, and that takes the current rotation using transform dot rotation. And the second parameter is the target rotation, which is this quaternion. I'm going to assign it to another object of type quaternion, and let's call it target rotation. And we can pass it in as the second parameter. And the last parameter is a float, which is like the smooth speed. I will use 20 times the time to delta time to make it frame rate independent. You could also add a variable for this value to adjust the smoothness. But this line of code is just creating the quaternion that will smooth the rotation. We have to assign it to the player using transform dot rotation equals this quaternion dot slurp. And let's try it again. And there you go, we can move the ball using the AWSD keys. The rotation is smoother than before. The only problem is that whenever I release the keys, he's facing forward all the time. We need to make sure to add this line of code only when we are moving. So I will just cut it, and then we can check if input.move is not equal to vector2.0 which means we are moving the player. In such case, we have to change the rotation. Otherwise, we don't want that. And there you go. Now we have a simple character controller. I can move it using the AWSD keys. You could also change the speed and the smoothness of the rotation if you want. In this third part, we are going to work on the camera movement. So we'll create this third-person camera that we can use to look around with the mouse. We have the collision, which is a cool feature for a third-person game. And as you can see, the player is moving to the direction where we are looking. So to implement a third-person camera for our game, I'm going to use the Cinemachine package that allows you to create any kind of camera movement. To do that, we have to go to Window, then Package Manager, make sure that Unity Registry is selected, and search for Cinemachine. I've already installed this version 2.8.9 using the Install button. And once you do that, you will be able to create a virtual camera. Under the hierarchy, let's right-click, Cinemachine, and we have Virtual Camera option. You notice that the camera moves to the same position of this object, and that's because it's controlling our main camera. So let's drag in our player holder to this follow parameter. We can change some other settings like the field of view. Let's use 50. We have the follow offset vector. We can change the offset between the player and our camera. If you are making a third-person shooter, you need to change the X offset so that you can see the weapons. For me, I'm going to use 0. And let's hit play. And there you go, the camera is following our character. For now, I'm using the transpose option as the body. Let's try a third-person follow. And this will give you more options. The same thing, we have the offset, we can adjust it, as well as the camera distance. So let's use 15 or maybe 12. I'm gonna move it a little bit to the top by changing the Y offset. For the X, I'm gonna use 0 because I want it to be in the middle. I highly recommend you to play with these settings. And there you go, the camera is following the player. If I rotate the player to the right side using the D key, the camera is rotated to the same orientation. It seems like the camera is in the same position. Let me bring the scene view over here so that you can check. To solve this problem, I'm not going to use the player holder as the follow parameter. I will create an empty game object under our player using right-click, create empty, and let's call it camera follow target. Then instead of using the player, I will drag in this object. Now we can easily reference this camera follow target and set its rotation so that we can rotate our camera accordingly. To implement that, I'm gonna go under the robot controller script and use serialize field, then transform, camera follow target. After that, I'm gonna create a function to control the camera rotation using void, camera rotation. We simply have to access the camera follow target, dot rotation. For now, I will set it to a 0 rotation using quaternion, dot identity. I haven't called this function yet. You could add it under the update function, but I recommend you to use the late update, so it will add a little bit of smoothness because it's called after the update function. And let's write the name, camera rotation. We have to select the player holder and reference the camera follow target. And let's hit play. And there you go, the camera is following the robot. And it doesn't affect the camera rotation because we are resetting the camera follow target rotation. Our next step is to take the inputs from the mouse. We have added this control's input actions, like the move action, which we have used to move our character. Now we'll use the look action. Let's use the player manager input script and add a function onLook, which takes in a variable of type input value. Let's call it value. So this function is called each time we move the mouse left and right or forward and backward. In such case, we will take that variation, which is a vector2. Let's create another public variable, vector2. I'm gonna call it look. Under the onLook function, let's use look equals value, then dot get vector2. Now we can take these inputs and use them under the robot controller. First, I will add two variables for the X and the Y rotations using float, and let's call it X rotation. and another float. For the Y rotation, I've already created a variable for the player inputs manager that has the look vector. Now we can move under the camera rotation, and we can use X rotation plus equals. Basically, we can add the Y value of the look vector using input dot look dot Y, and we're gonna rotate the camera around the Y axis so that we can look left and right using the mouse X variation, using plus equals input dot look dot X. Finally, we can create a quaternion based on these values. I'm gonna call it rotation equals quaternion dot Euler so that we can pass in the angles. For the X, I'm gonna use the X rotation. For the Y, let's use the Y rotation. But for the Z, I'm gonna pass in 0. And finally, we can assign this rotation to the target so that we can rotate the main camera. Let's save our script and let's hit play. Now we can rotate the camera and look around. To fix this problem, I'm going to clamp the value of the X rotation using X rotation equals, and let's use mathf.clamp, which takes the value that we want to clamp, which is the X rotation, and the minimum and the maximum value. For example, I want it to be between -30 and 70 degrees. I recommend you to add two variables for these on top. Let's save the script again and check the result. The X rotation is limited to be between -30 degrees and 70 degrees. So if the camera hits the ground, we can't see it because we're not checking for collision between the camera and the ground. To fix that, we can select the virtual camera. Luckily, we have the option to check for the camera collision. For now, it's not checking for any objects. We can select our ground and assign a specific layer to it using add layer. I'm gonna use ground. Then let's select it again and change its layer from default to ground. Last but not least, we can select the virtual camera, and we need to tell it to check for collision between the camera and the objects that has the ground layer by selecting ground. If the camera hits the ground, you see that we have this kind of movement, and that's what we want. And the final thing that we have to fix about this camera movement, for now, if I hit the Z-axis to move forward, the player is still moving to the same direction, which is the forward vector. And that's because we have created the target direction using the move vector. We have to take into consideration the camera Y rotation. So let's rename this vector to be the input direction that is created using the move X and Y values. The same thing, I'm going to create a rotation based on this vector, input direction, but we're going to add the camera Y rotation to this value. Of course, we have to add a reference to it on top using serialize field, and let's declare it as a game object and call it main cam. But we can't add the Y rotation to a quaternion that has XY values. That's why I'm going to change this variable to be a float, which is the target rotation, equals quaternion.lookRotation.input direction. And to get the Y rotation, we use dot Euler angles.y. Then we can add the main camera Y rotation using main cam dot transform dot rotation. The same thing, dot Euler angles dot y. So we have this error because we have used the target rotation in the previous video as a quaternion so that we can change the player rotation. We can create it again using quaternion and call it rotation equals, then let's add quaternion dot Euler. For the X, I will use 0. Then I'm going to use the target rotation, which is a float, and it's the Y rotation that we need. And finally, we can use this new quaternion to rotate our player. Now that we have the target rotation that we need, and it is created using the inputs as well as the Y rotation of the camera, we need to get the direction based on this rotation. So let's create a vector 3 and call it target direction. And the expression is a little bit weird. Basically, we will take the vector 3.forward, and to rotate it using the target rotation, we have to multiply it by the quaternion target rotation. And I think that's pretty much it. But we don't need to create the target rotation if we are not moving. So I will take this line of code and I'm gonna set it to 0. Then I will assign the value under this if statement. That means when we are moving, we need to calculate the target rotation. First, make sure to reference the main camera object. And let's hit play. For now, we can rotate the camera so that we can look around. And let's try to move forward. The player is moving forward so fast because I have made a mistake. Here we are multiplying the forward vector by a float, which is the target rotation. Actually, we have to set it to a quaternion so that we can rotate the vector. Dot Euler and pass in 0 for the x, then the target rotation, and 0 for the z. Let's save it again. And it doesn't work. The player starts moving without pressing the AWSD keys. Don't worry, everything is fine. Actually, we have used this speed variable and it is initialized to 4 by default. I'm gonna rename this variable to be move speed. And I'm gonna add another float on top. I'm gonna call it speed. By default, it is 0. And once we start moving, I'm gonna change it to the move speed, which is 4. And there you go, we have finished this third-person camera movement. Now we can look around with the mouse, and the player is moving to the direction where we are looking. When I hit the control key, we'll be able to change our character to a ball. In this mode, we can move it with a different speed, so he's a little bit faster. And also we can get back with the control key. We have a basic third-person controller. We've added the camera controller. Now we want to switch it to a ball mode when I hit the control key. And to do that, first we need to modify the input actions. If you don't know, we are using the new input system. Make sure we are using the player action map. Then let's hit this plus icon. I'm gonna call it switch mode. Then we can set a binding, which is the trigger for the action. In our case, we're gonna use the control key on the keyboard. From the binding properties, let's select a path. I'm gonna use listen and hit control. Then we can easily select it. If you want to add more actions for a gamepad, you could add another one using the plus icon, add binding. Then you can select another path for a gamepad, like the right trigger. If you add different bindings, you have to select the right one. Here we are using the gamepad. For the control key, we are using the keyboard and mouse. And that's pretty much it. We can save this asset. Then I'm gonna open up the player inputs manager that manages the inputs. Let's start by creating a public boolean and call it switch mode. And each time we press the control key, we are going to change it to true so that we can switch the mode. To do that, we add void, and the name needs to be like this, on, and the name of the input action, which we have called switch mode, which takes in an input value object. I'm gonna call it value. And finally, we can change our boolean switch mode using equals value, then dot is pressed. So this returns true when we hit the control key. After that, we can use our boolean, which is public, under our robot controller script. Recently, we've created these lines of code to move the player using the AWSD keys. Let's make things cleaner. I will take these lines of code and put them inside another function, void. I'm gonna call it move normal when we are in the normal mode, and paste it using Ctrl V. First, I will create a boolean to check whether we are in the normal mode or the ball mode. Let's go on top and add private boolean. We can call it isBall or ball mode. By default, it is false. And under the update function, which is called over and over again, we can check if we have pressed the control key using the input object, then dot, the name of the boolean, switch mode. In such case, we have to reverse the boolean ball mode using the exclamation mark, ball mode. First of all, the ball mode is false. When we hit the control key, it becomes true. And the next time we hit control, it becomes false again. Then we have to reset this boolean using input dot switch mode equals false. I highly recommend you to use functions so that you can clean up your code. Let's cut these and create void switch mode and paste it using Ctrl V. Then let's call it on top under the update function. Last but not least, we can check if we are on the ball mode using if ball mode. We're gonna call a function move ball We haven't created this yet. Otherwise, we can call our normal move function, move normal. We mostly need the same lines of code to move our ball, so I will create it using the same lines of code and call it move ball. We're gonna tweak it a bit so that we can create a different movement when we are in the ball mode. For example, we can use a different speed by changing this move speed to roll speed. Let's create this variable on top. I will use Ctrl D to duplicate it. The same thing, it's float, and call it roll speed, like 13. Then under our second function, move ball, when we are moving, we are going to set the speed to be the roll speed. Now let's save our script. By default, the character is in the normal mode. And if I hit Control, nothing happens because we haven't changed the animation, but the speed is increased. Now he's moving faster. Let's hit Control again, and he's slower. So let's work on the animator component. Recently we have created this blend tree that contains the idle and the walk animation. Let's give it another name, like normal mode. And once we hit the Control key, we need to play this animation. We can drag it under the animator component. Then we can make a transition from the normal mode to this animation close. And to control the transition, we need to add a parameter using the plus icon. And let's set a boolean. Let's call it ball mode. Then we can set a condition for this transition. And I think you guessed it. We're gonna set the condition to the ball mode true. Then we can get back to the code. We've already added a reference to the animator component. Now we can go under the switch mode function and change the boolean that we have created. Whenever we switch the mode, we can use animator, then dot, set boolean. Make sure to write the same name, which is ball mode. I'm gonna copy it and paste it as the first parameter. We simply have to change it to the ball mode boolean that we have created on top. Now let's save the script again. Then I'm gonna hit Control. So it takes a little bit of time to switch to this mode. To solve that, we need to remove has exit time from our transition. If you uncheck it, the player will switch directly to the animation. And there you go, now we can hit the Control key to switch to the ball mode. In this mode we have different speed, which is 15. We need to work a little bit on this animator so that we can get back to the normal state and play the roll animation when we are moving. First I will add the roll animation, which is this animation. Let's drag it under the animator component. Basically we can play it once this animation is finished by making a transition to this roll loop, and you don't need to set a condition, just keep has exit time. Next we have to change the speed of this animation depending on whether we are moving or not. And to do that, we can go under the inspector and check this multiplier parameter. Now we can create a float that we can change from the code, and it will be multiplied by the speed of this animation. First let's create it using the plus icon. It's a float. I'm gonna call it roll speed. Then we can set it as the multiplier. And our second function, move ball, comes in. Instead of changing the float speed, I'm gonna change the roll speed. The same thing, we can set it to the magnitude of the move vector. So whenever we are moving, it's gonna be 1. And that's exactly what we need. It will control the speed of the animation, roll loop. You can play around with the roll speed parameter. I'm gonna set it to 25 and hit play again. And yeah, I think it's better. If I hit Control again, nothing happens because we haven't added this logic to switch back to the normal mode. The same thing, we can take the open animation. I think it's this one. Let's drag it under the animator. Then we can make a transition from the roll loop to this open animation. Make sure to remove has exit time. And as a condition, we can use our boolean ball mode. When it becomes false, we can switch back to our normal mode. And finally, we can make the transition to the normal mode blend tree that contains the idle walk animations. You don't have to set a condition, just make sure that has exit time is checked. We can go to the ball mode. In this mode we have a different speed, and also we can get back. If we are moving and hit Control, maybe we should use another animation, like this animation, if we are rolling. And to do that, we can go back to the animator component and drag in this second open animation. And we will have two options. if we set the Boolean ball mode to false and the roll speed is less than a certain range, like 0.2, that means we are not moving and we have hit control. In such case, we need to play this normal open animation. But if the roll speed is greater than 0.2, we are going to play the second one. So make sure to add the two conditions. When we set ball mode to false and the roll speed is greater than 0.2 and remove has exit time. Once the animation gets finished, we have to switch back to the normal mode animations, and you don't have to set a parameter like this one. We can improve this a bit by putting all of these animations inside another state. If I hold down the shift key, the player is moving faster. And to do that, we have to open up the controls that we have created recently. Under the player action map, we need to add a new action for sprinting using the plus icon. Let's call it sprint. We have the action type. So if we have a continuous action, like holding the shift key, it is recommended to use value or pass through. Then we can select a trigger for this action, which is holding the shift key. From the properties window, we can listen to the binding when I hold the left shift, and here it is. Then we can save this asset, and let's open up the player inputs manager. Basically, we have to add this void on sprint function. Make sure to use the same name of the input action that we have created, which takes in an input value and call it value. Then we need to create a variable so that we can use it later on to check if we are sprinting or not. Then we can use our action to change its value. Sprint equals value, then dot is pressed. Now we can use it for our robot controller script. We have added a logic to change our character to a ball. I don't want to add the sprint feature to it. That's why we need to change that under the move normal function. We have created the speed variable. By default, it is set to 0. And when we start moving, we have assigned the value move speed. We can add another if-else statement to check if we have sprinting enabled or not. I'm gonna cut this line of code and use if input.sprint. In such case, we will change the speed to another speed that is higher. We're gonna call it sprint speed. And if we are not holding the shift key, we're gonna use the move speed, which we have created on top, and it is 8. Let's duplicate this line of code. I have used Ctrl D and call this sprint speed like 11. I think it's okay. For now, we have the normal speed. And if I hold down the shift key, you see it has changed, but we haven't changed the speed of the animation. And to do that, we have to go under the animator component. Recently, we have added this blend tree that blends between the idle and the walking animation according to the speed parameter. Now we want to add the run animation, but this character doesn't come with a run animation. We could simply use the walk loop animation and change its speed from the properties window. So let's select this blend tree and add the third motion using the plus icon. Add motion. We will use the same walk loop animation from our project. We can select it from here and drag it to our third motion. Luckily, we have this field to change the animation speed. I'm gonna change it to 2. And let's test it by selecting the blend tree and the play button. For now, the speed is set to 1, and that's the value to trigger the third animation. As you can see, he's so fast. We can modify this parameter to adjust the player speed. For now, he's idle. Then we're gonna set it to the walking animation. And if we are sprinting, we are going to change it to 1. I guess he's so fast. Let's change the speed to 1.5. And instead of using the threshold between 0 and 1, I'm gonna use 0 and 2, because we have used the range 0, 1 to change the speed of the player when he's walking using the AWSD keys. To do that, we can uncheck automate thresholds and change the threshold to be between 0, 1, and 2. Then we can get back to the code. Under the move normal function, we have used animator.setFloat to change the speed parameter. When we are moving, the magnitude of the move vector is 1. That's why we have the transition between idle and walk. The same thing, we can change this value according to whether we are sprinting or not using if input.sprint. In such case, we're going to set it to 2 so that we can switch to the run animation. Otherwise, using else, we're going to change the speed using the input.move.magnitude as usual. And let's hit save. And there you go, now we have added the sprint feature. I'm holding the shift key and the animation has changed. If I release it, we are in the normal moving animation. We have added this feature to change the character to a ball. Of course, we can't use the sprint feature here because we have added that under our move normal function. And before I finish this video, I'm going to show you another way to implement this if-else statement. I think it's a little bit long. We can write one line of code that implement the same logic using speed equals. Then we add the condition, which is input.sprint, and the question mark. If this condition is true, we're going to set it to the sprint speed. Then we add colon and the other condition. So if it's false, we're going to use the move speed because we are not sprinting. And that's the same logic of these lines of code. Let's get rid of it. Instead of writing all these lines of code, let's use this line. And here we're going to pass in our new form using input.sprint, then question mark. If this is true, we're going to set it to 2. Otherwise, we're going to use the magnitude of the move vector. And let's hit save again and see if we have the same results. I can use the shift key to sprint. I have noticed one problem. If I hit shift and I'm not moving, we have this run animation. And that's because we are setting the speed. Even if we are not moving, we can cut this line of code and put it inside this if statement. When the move vector is not 0, then we can change the speed parameter. Otherwise, using else, I'm going to set it to 0 so that we can play the idle animation. If you have any question or comments about this project, make sure to write it under the comment section down below. In today's episode, we're going to add the jump ability to our 3D character when he's in the ball mode. When I hit the spacebar button, we can jump. So first of all, we need to check if we have pressed a specific key, like the spacebar button, to jump. We need to open up the controls input action. Recently, we have added the input action, sprint. Let's add a new one and call it a jump. For the binding, I'm going to use the spacebar button from the path property. Let's hit listen, then space, and select it. If you want to add a specific key for the gamepad, you could do that by adding a new binding. Then we can save this asset. After that, we need to open up the player inputs manager script. Recently, I have added this boolean sprint. Let's add a new one, boolean, and call it a jump. Let's go down and write the function on jump. In such case, we're going to change the jump boolean. Before that, this takes an input value. Then we can use value dot is pressed, which returns true each time we trigger this action by hitting the spacebar button on the keyboard. Now we can save the script so that we can use this jump boolean under the robot controller script. I've already added a reference to the player inputs manager and it is called input. Before that, I want to add few variables to set some parameters like the jump height or the gravity value. For that, we need to add serialize field so that we can adjust these variables from the inspector. And let's start with the gravity value. I'm gonna set it to -10 and we're gonna need the jump height and let's set it to 2 units. Last but not least, I will add a vector 3 to change the velocity of the character controller so that we can jump. We don't need to adjust it from the inspector and let's call it velocity. Now we can go under the update function, which is called over and over again, and call some kind of jump and gravity function to check for that. Let's create it down here using void. It is called jump and gravity. We can check if input dot jump, and I want to add it to the ball mode because we didn't have a jump animation. So we need to check and we are on the ball mode using this boolean which we have created recently. In such case, we'll change the velocity y value, and here we have a little bit of math. We we need to set it to mathf dot square root, and we pass in the jump height times 2 times the gravity. Sorry, here we have to change the y value to move it upward, but this gravity is a negative value. We need to add minus. Next, we need to make sure to reset the jump boolean using input dot jump equals false. Finally, we can use the character controller component to move the player using the velocity vector by calling the function controller dot move, and it is built in. Here we pass in the vector velocity, and let's multiply it by the time to delta time to make it frame rate independent. At this point, the velocity vector is not affected by the gravity. We need to go on top and add velocity dot y plus equals the gravity and multiply it by the time to delta time to make it frame rate independent. Let's save our script and give it a try. First, we need to switch to the ball mode by hitting Control, and let's hit space. And there you go, we have the jump ability. Also, we can move and jump, but we can make multiple jumps because we are not checking if the player is on the ground or not. For that, I will create an empty game object under this ball to check whether it is touching the ground or not. Let's right click and create empty game object. Let's call it a ground check and make sure it is under the player by adjusting the y value. So 0 is fine. Then we can get back to the script. We need to add a reference to the object that we have created using serialize field. We only need the transform component, and let's call it a ground check. And I want to add another boolean and call it is grounded. And to check if the player is on the ground, let's go under the jump and gravity function. Then I'm going to use the built-in function under physics, and it is called check sphere, which will create an invisible sphere. For the origin, I will use the ground check object dot position. Then we can set the radius like 0.2. The last parameter is a layer mask. Basically, it creates an invisible sphere, and if it's touching an object that has this layer mask, it will return true. Usually I call it ground layer. I'm gonna add it on top using serialize field so that we can set it. The type is layer mask, ground layer. If we save our script and go back into Unity, we can specify the objects that we need to check for, like the ground, by selecting the player holder, and we have this ground layer. By default it's set to nothing. I've already created this ground layer. I'm gonna select it, and it is assigned to the ground object, which is this plane. If you haven't added yet, you could go under add layer and add a new one. Then make sure to assign it to the objects that are supposed as a ground, and that's the optimal way to check if the player is on the ground. Now we can go under here and check if we are on the ground using this boolean is grounded. In such case, we will be able to jump using the spacebar button. And that's pretty much it. This is gonna work just fine, but we can improve it a bit. Here we are applying the gravity to the velocity vector all the time. We need to do that if we are not on the ground. Under the else statement, let's add this line of code, and let's go back into Unity. First, make sure to reference the ground check object by selecting the player holder and drag in the ground check object. I want to change the jump height to 3. Let's hit Control, and there you go, we can jump using the spacebar button. I'm gonna show you how to add mobile controls to the third-person controller that we have created recently. As you can see, we can move it using the joystick. Also, we're gonna add this button to switch to the ball mode. In this mode, we have a different speed. So I highly recommend you to watch this video until the end. And without any further ado, let's dive right into it. In today's episode, we're gonna add mobile controls, and it works with the new input system. So you could use this for your projects. First of all, you will need to download this folder that is called Mobile Controls. You could download it from the link under the description of this video, or you could get it by creating a project under Unity Hub. Make sure to select a third person. You will find a Mobile Controls folder that you could use for your game. For me, I will simply extract this, and let's import it into Unity. I'm gonna put it under the Assets folder. Then we can go under Prefabs, Canvas. You have two options. The first one is using joysticks to move the camera and the player. And the second one is using a touch zone. You could drag your finger to move the camera and move the player as well. Let's start using this one. And there you go, we have two joysticks. Also, we're gonna add a third button so that we can switch to the ball mode and get back. In our previous videos, we have created a C# script that handles the player inputs, and it is called the Player Inputs Manager. And it is setting these variables that we have created to move the player. Instead of assigning these values that works with the computer, we're gonna read the inputs from the joystick, and the script that is responsible for that is attached to this canvas, and it is called UI Canvas Controller. Let's open it up. This script is created under a namespace starter assets. I'm gonna get rid of it. We don't need that. Then we need to change this variable. It is the script that handles the input. In our case, it is called Player Inputs Manager. Let's change the name. I'm gonna copy it and use it under here so that we can access these variables to move our character from the mobile controls. And I'm gonna call it inputs. Then we have few functions like the virtual move input, and it is called automatically each time we use this joystick. In such case, we're gonna use this vector to move our character. For that, we need to access the move vector using inputs dot move equals the virtual move direction that changes when we use the joystick. The same thing applies for the camera movement. I'm gonna use inputs dot, and the vector is called look equals the virtual look direction. Then we have this virtual jump input that is called each time we press the jump button. In such case, we will access the jump boolean under the player manager input script using dot jump equals this virtual jump state boolean. And finally, this printing. For now, I'm gonna stick with these functions to control our character. Make sure to save the script. Then we have to select the canvas and reference the Player Inputs Manager, which we have attached to the player holder, and it is called the Player Inputs Manager. You could simply drag the player holder. Next, I'm going to change the project platform by going to File, Build Settings. Instead of using Windows, Mac, and Linux, let's select Android. If you haven't this option, make sure to install it. And let's click on the Switch Platform button. Then let's close this window. At this point, we can't use these buttons because we need to add another component, and it is called the Event System. It is under the Mobile Controls folder. Let's drag it, and there you go, it is working. For now, I can't use the sprint feature because I have one mouse cursor, but I'm gonna hit Control so that we can switch to the ball mode and test the jump ability. So you see, it's really simple to use these mobile controls. Now let's add the third button so that we can switch to the ball mode. For now, I'm using the Control key. For that, I will duplicate this button, Sprint, using Control D, and let's move it. And let's call it Switch Mode. Next, I will change the icon of this switch button by selecting Image Icon. For now, it is set to the Sprint. Let's use another one, like this circle. Finally, we have to change the function that is called each time we press this button. So from the inspector, you see that we have this button state output event, which is something that is triggered each time we press the button. In such case, we're gonna call a function under the UI Canvas script that is attached to this UI Canvas. Let's open it up again. To save a little bit of time, let's copy this function and call it virtual switch input or change mode input. Then we use inputs and the name of the variable, which is called switch mode. If we change this to true using dot switch mode equals the boolean, I'm going to change the name as well, virtual switch state. Finally, we have to save this script and call the function. Make sure to select it from here, UI Canvas Controller, and it is called virtual switch input. And let's give it a try. If you don't want the joysticks, we have this second option. Let's disable this one. In this canvas, you could control the camera by dragging your finger. You have to follow the same process. First, you need to reference the Inputs Manager script and add the buttons that you want. I'm gonna get rid of it for now. And let's enable this. To be able to build the game, you need to install few modules. Under installs, I have this version of Unity. We can go under add modules. I've already installed the Android build support as well as the OpenJDK, SDK and NDK. These are required to build the APK file. If you want to make a game for iOS, make sure to select the iOS build support and hit install. Then we can go to File, Build Settings. For now I have this little warning. We need to go under the player settings again. They said that we need to switch to this color space. And let's get back to the build settings again and hit build. This will generate the APK file. I'm gonna call it build test. Then hit save and save again. And once it's done, we can take this APK file and put it on my smartphone to test it. I've already plugged the USB cable. Then let's copy it and paste it under the phone. After that, we can install it by going to the files. And here's the name, buildtest.apk. The steps are really simple. Then we can open it up. We can switch to the ball mode by hitting this button. And we can move using the joystick. For now, I can rotate the camera by dragging on the screen. Maybe we should disable the PC controls if we build this game. Or I'm gonna create another boolean to enable or disable the camera movement using public boolean. And let's call it lock camera. And under the onLook function, we can check if lock camera. In such case, we need to return. Then we can save the script and select the player holder. I'm gonna change this to true to lock the camera movement and build the game again. And now the problem is fixed. We could only move the camera using the joystick. So I think that's all for this video. I hope you like it. If you have any question or comment, make sure to write it under the comment section down below. And I will see you in the next one.